Good evening, I'm Brian O'Connor, Chairman of the Water Pollution Control Authority. It is Monday, October 27th, 2025. The time is 8:54. I'm calling this meeting to order. Before we begin, just want to think about the people out in Jamaica and in harm's way of Hurricane Melissa, and portions of tonight's meeting will have to do with coastal resiliency, so think about that as we're going through the night. Right now, I'm looking for a motion to approve the minutes of the WPCA meeting held on September 22nd, 2025.
So moved.
We have a second, Mr. Afria. Any discussion? All in favor?
Aye.
Moving on to item 3, the report of the town engineer. We are going to have a presentation, so if you don't mind, will you all join me?
Did I break it? That was good timing, huh? Can you see all right if I'm standing here? Over there? That's all right. Well, hello, everyone. My name is Fred Mueller. I'm Vice President at Time Bond Engineers. I'm here to present the results of our study that we did along with Emmanuel, our project manager. This is all about your WPCA, your Water Pollution Control Authority, a resiliency upgrade study. And as you probably know, your facility is located within the floodplain. There's been flood protection for years, but now you're going to a new phase because you're constructing a new flood wall that will retain stormwater within the site during high river conditions. And you need improvements to keep that stormwater out of that facility. And we'll get into the details on that, how it works. I'm going to come over here if this works better. I like to move around. One of the challenges is that stormwater flows into the WPCF from the wetlands over here in that neighborhood, and it passes through. It's going to pass through the new flood wall. And the challenge is that the amount of stormwater that can flow through this from the wetlands here or through the tidal wetlands is well beyond the capacity of the existing effluent pump station at the treatment plant. So during minor storms and minor flooding, yes, the treatment plant will pump out the stormwater here, but during major floods, the river is basically going to inundate this site. So we can't pump the river. And we've got limited capacity here to pump both stormwater that lands inside the station, inside the treatment plant, out to the river through the effluent pump station. Another thing that I'm going to talk about, or Emmanuel will talk about, is the fact that there is a gravity outfall over here that allows the wastewater to flow out during low tide. And so that exists as well. And that'll become important a little bit later on. So the project scope and goals and approach was to figure out and evaluate ways to manage the external groundwater, the external stormwater, minimize on-site runoff so that the stormwater that hits inside the site can be minimized, the peak flows that's generated from that. And those two things, Emmanuel is going to talk briefly about it. We looked at a number of options and we're recommending the best option, and that is an option that's going to minimize the amount of stormwater that has to get pumped out of the site. We can do some on-site storage, that kind of thing. We evaluated the pumping capacity of your existing effluent pump station, and we looked at options to increase that capacity and that's kind of be the focus of tonight. And we're going to plan for a number of improvements at the plant that includes lining of stormwater and effluent pipes, replacing stormwater piping from the western neighborhood, other improvements including gates that have to get replaced so we can keep that stormwater out and protect the plant. But the key issue tonight is to look at the options to improve the effluent pump station. That's the decision-making process tonight. Also included in our scope was to review and assess the permit requirements for the upgrades at the plant, which we're not going to spend any time on that, but that's included in our report. And with that, I'm going to turn it over to Manuel.
Thanks, Fred. As Fred mentioned, the plant is actually in a flooded area in an AE zone, and there's a portion of the wetlands that actually goes through into the plant, and the effluent pump station pumps that out into the Houstonic River. So currently the effluent pump station has the capability to pump plant effluent, on-site stormwater, and external stormwater. We had to do an analysis as part of our scope to identify how much this pump station will be able to handle and what are some of the limitations. So we conducted hydrologic and hydraulic modeling for that. So this table shows the stormwater generated off-site and on-site for different frequency of rain events. Typically, 100-year frequency is used in sizing stormwater infrastructure. So there are a lot of numbers here. The one in parentheses is million gallons per day. So those are the numbers I'll talk more about, just because wastewater is mostly done in gallons per day. So the first line that you see is the existing condition. That's the on-site stormwater, the external stormwater for a 100-year frequency. You can see it's 31.2 MGD. What we tried to do is we tried to reduce the amount of external stormwater that comes onto the site. That's condition number one. So we downsize the pipe size. So the second line you can see is 30.6, so it slightly went down. What we also, the third option was we ended up putting in a detention system on site to store the on-site stormwater generated. So it went further down. But overall, 3A, the proposed 3A condition was the lowest option of all, where there's no external stormwater coming into the plant, and that condition would take into account a detention system where the effluent pump station would be pumping out plant effluent, and the detention system would provide some amount of relief for the on-site stormwater that's generated to the plant. As part of our study, we also found out that we also identified that there's impervious areas, pervious areas, and there are open tanks on the site. It's 11-acre site, and the open tanks equate to 2 acres. So that results in somewhere around 10.5 MGD of rainwater that's collected in the tanks during a 100-year storm event. So basically, we went with the lowest option, which is 3A, which is 20.2, where there's no stormwater coming in from the outside. There's only stormwater from the inside and the open tanks, which results in 30.5 MGD. So that's the option. So key findings, as you can see, there's no external stormwater. On-site stormwater, which we just looked at, was 20 MGD. Open tanks was 10 MGD, so that's 30 MGD. Also, the effluent pump station actually convey wastewater. The NIPD's permit for the facility, average flow is 11 MGD, and a peak hour flow is 39 MGD. So for a worst case condition, which is 39 MGD plus these two added, that's 69 MGD that the pump station will need to pump out into the river. We also did a drawdown test for the 3 pumps. Each pumps are rated for 26 MGD. Based on the drawdown tests, we found that 2 pumps can put out 44.8 MGD, which basically means that during a 100-year storm event where peak hour flow is happening at the same time, the site would be flooded by 44 minus 69, somewhere around 20 MGD, which would have devastating impacts to the site, the UV system, the electrical equipment. If we choose to run 3 pumps, typically if you're pumping in plant effluent, Connecticut Deep requires an N+1 option. Basically, you want the third pump to be as a spare, just in case if there's any damage to the pumps, if there's any repair work happening. So this scenario is not recommended, but in that case, if we run 3 pumps, we still are not meeting the requirements. So basically, we came up with 3 options. Option 1 is a do-nothing alternative, which costs $5.2 million. And for this option, there's no pumping improvements, but there are other improvements at the plant. Option 2 would be to expand the existing pump station. That would be $7.2 million. And option 3 is $7.5 million, which is building a new stormwater pump station. Right now, the town has a FEMA grant approved for 4.1, and they've appropriated 1.39 million to date. So talking a little bit about these options. So this is option 1. Under this, these would be the list of modifications that would be completed, and it wouldn't have any pumping capacity, which Fred will talk about, the pros and cons of each of the options. Option 2 is the existing pump station, expanding that. So basically, the flow comes in from here, and there are 3 pump stations which pump into this pipe into Long Island Sound. So we would add in a new structure here, put in a new pump. So this is actually the expansion concept. So basically, that would be here, and we would tie that back into the existing force main. So that way, now we would have 4 pumps to meet that increased capacity. So that's option 2. Option 3 would be to build a new pump station right where the diversion structure is. This would pump in both a combination of stormwater and plant effluent into the diversion structure and utilize the outfall, which actually is used for gravity flow. So with that, I'll turn it over to Fred to talk about the advantages and disadvantages of each option.
Thanks, Emmanuel. All right, option 1, do nothing. I don't really like that title because you're spending $5.7 million, but that's really do nothing with the pump station. There's a lot of improvements that have to be done inside the plant. And as you probably guessed already, the flood wall improvements aren't included in this either. All right, disadvantages, you don't have any redundancy. That's what no N+1 reduction. And anytime we design a plant, we always design for reduction. We design for redundancy. Give the operators a backup, fallback. So if a pump does go out of service, they can maintain it and still have full confidence they can do what they need to do. So you don't minimize, you don't reduce the plant flooding risks. And what it really means is if you get a bad enough storm, and it's a perfect storm, the plant flow's coming in, you've got 40 million gallons a day coming into that plant, and it's raining right hard, and the river's at the highest level, you're going to damage the plant. You're going to be in trouble. The first thing that'll go is your UV disinfection system, and that's what keeps the water clean in the river in the summer. And if that gets damaged, you could be out of service. That could be out of service for months and months before it gets repaired. As well as other parts of the plant will get damaged. The expand the station option number 2, gives you that redundant pump, as you heard. The challenge we're going to have is there's underground utilities feeding that, and finding the room to fit that pump in could be a challenge. So there's some risk there. In the design, to go that route, we're going to have to do some checking, more details on the underground utilities to find them, and the cost of relocating them if we go that route could drive up those costs. So there's risk there. And you're doing work in an existing pump station, so there'll be high bypass costs. Again, creating more risk. We've got to bring in temporary pumps to make that work. Option 3 is to build a new pump station. Costs a little bit more money, provides redundancy. It can be constructed with minimal bypass pumping. I like that. It can be used to bypass the effluent pump station for maintenance. Right now, if they had to shut down the existing effluent pump station, they have no other option to bring in temporary pumps. If we built this separate pump station, then we have some flexibility in doing maintenance of those other pumps, which is an added benefit. It also uses that existing far outfall that sends the wastewater out farther into the river, not exactly Long Island Sound. It gets there eventually, but into the river. And that's nice because then you don't have your treated wastewater just rushing out by the boat docks there, by the thing. And that could be done all the time during low flows, or you can sequence from one pump station to the other. The other thing is, and this came out when we went to the vendor who sold you, who provided the pumps that are out there now, and we looked at the pump curves and they said, those pumps really shouldn't be operating the way they operate now. They're designed to pump high levels of flow, but they're not really designed to run on a day-to-day basis, pumping out 4 million gallons a day in the middle of the night when the wastewater flow is designed. And maybe that's the reason why these pumps, which are 20 years old, which is a good life, they've been rehabbed once, so I can't say that it's been terrible, but when we did the pump tests, the pumps are definitely worn. The low flow with the two pumps, the numbers with two pumps running, those are the two most worn pumps because we always size firm capacity based on the largest pump out of service. So there's definitely some wear. They've been rehabbed. It was about 10 years ago. They're going to need it again, if not, or replacements. But the best way to preserve their life, I think, is to size a new pump station that'll handle the day-to-day flows, low flows that the plant's seeing now. And that's the last bullet there. It reduces the wear on the existing pumps that are not intended to pump low flows. Yes?
So, you just said that, and just correct me if I'm wrong, you said that the pumps that's there now are not designed to do, what it's doing. In other words, somebody designed or spec the wrong pump, is what you're saying?
I don't want to put it quite that way, but when we look at pump curves, right, and the curves that the manufacturers gave the engineers years ago didn't show the back half of it, which part of the curve. And when they sent it to us, they said, we really wouldn't recommend running these pumps down on that side of the curve. That's just how we designed it. So if we were to go with option 2, I'd be recommending we find a different pump that's a different pump than what you have in there now. So it wouldn't be the same exact model. And they've already recommended a different option for the pump. But the pumps have served you for 20 years, but I think the sign is that they're wearing, and that. Can I say that it's related to it running back there? I really can't, but my advice is we would never put in that new pump, that same style pump again. So all the pumps we're recommending are different from the other one, the ones that you have now.
I would suggest, that since you're saying that those pumps that they're using now shouldn't have been designed to do.
I'm saying the pump manufacturer would not recommend us using them as they are now.
I don't want to be counting the words, but I'm just
Yeah.
saying. So, and then so option number 2, right? Even though you have 7.2 million there,
Yep.
the fact that you said with the electrical stuff that's underground, if it gets really messy down there, it can be more than 7.2.
It may come down to the point of it gets more and more expensive, and why are we going down this road? Right.
And so as part of our scope, as part of the 30%, if we go with, so we've given our fee for all 3 different options. If the town chooses us to proceed with option 2 or 3, we'll do geotechnical borings, we'll do some excavation or prior to coming up with a concept to see which one's the lowest cost. So option 2 and option
Sure. Oh, sorry.
No, I was just gonna say, you know, to that point, you know, the safer option, in my opinion, the safer option is 3 because, again, you don't know what's happening underground. You know, you can't put a number to it till you get in it.
Yep. Yes.
Just to zoom out on some of the projects, so obviously we're doing a separate project to build the flood wall around that to prevent water from coming in. This project is looking at, provided we do that effectively, this is the second project about how to deal with the water that's in the plant.
Right.
And there's obviously two types of flooding, right? There's the water, the sea level rising up, and then there's just precipitation coming down. And what you're saying is, this stuff for what's going on inside is to combat the worst case scenario where you have enough precipitation on the site and inundating our pipes to send more in through, like high flow in through the pipes into the plant as well, while we have high sea level, like a storm surge event. That this is sort of what we need to deal with to protect that.
Right. This is what we need to do to protect the
We
plant.
currently have 3 pumps in an old pump building. Is that correct?
Yeah, the original pump building was built in the 70s. The pumps were replaced in 2006-7 timeframe.
Those pumps can handle, if they're all working ideally, 66 million gallons a day.
Right.
And you're seeing an event in the 100-year horizon, it could be 69. And this solution of the new station would be one new pump that works in conjunction with the 3 existing in the old one, and this one especially works well on the lower end of the use spectrum.
And option 3 would actually include, instead of one big pump, it would include several. I think our concept is based on three pumps.
3 small pumps that would better handle the normal use of the spectrum. So the old pump house would sort of be an extra pump plus high flow pumps for more regular interval
right.
high flow events.
Right. Correct.
Fred, can you go back to, I think it's slide number 2, with the current challenges?
Slide. Tell me what it.
Slide 22. Current challenges.
Current challenges. Got it.
So you were talking about, adjacent to the property on the left side of the picture, about flooding that happens in that community that seeps into the stormwater. I was thinking about a development that's happening at the southwest of that picture, and how that
Down here.
property is raised to a certain degree, and how that stormwater runoff with the piping continue to inundate flow towards the direction of the WPCA. So in that instance, we're planning for the 100-year flood, but the conditions that are set up now is that this is an issue that we have to address within a reasonable time. We can't wait on this.
Right. Your flood wall, in order for your flood wall to be effective and protect your plant, we have to move forward with a pump station upgrade. Yep.
So my question is, in that community, it's further down Main Street, but it is affected by the sewage plant because it goes in the marshland. So I heard you, I didn't know if I understood you correctly, the new pump would push the water out further, like there. So if there is any, would that help the seepage that's happening already?
So the existing pump station is here, and we have an outfall here. The gravity outfall that the plant has had for years and years, but is only effective during low tide. They can only run it during low tide, comes out here. And, you know, we're talking about putting the pump station here and using that outfall to get the water out, as opposed to doing it here where it's more congested with utilities. There's some old tanks over here that have been abandoned, so there's much less risk.
That's a complaint we very rarely often, so that could help over time. It wouldn't be a
Yep. And that's definitely the advantage of going with the pump station upgrades, because you'll be able to better protect this community here from flooding. With more capacity, you can wait longer and longer before you have to shut off the gate here that lets their stormwater in. But as I said earlier, you can't really stop the river from coming through here. Once the river's going through, you can't pump the river back to the river. It's just not going to work.
With, these options, the one thing it shows in the printed version, right, there still is going to be the cost of rehabbing the existing 3 pumps in the old house if we go with this, third option. Any idea ballpark what that will be to rehab those existing pumps?
I don't have that number off the top of my mind. Tom, do you remember how much it cost you 10 years ago?
For rehabbing the 3 existing pumps in the old pump house?
So the advantage with option 3 is you're using this pump for a lesser duration because the
Right, it's gonna extend their life anyway,
Yeah.
I mean, it's still good, I see that you have the big, red text on here, that that's something newer. Any other, and I know for option 3, you don't have any
Oh.
cons listed there, other than it's obviously the highest cost, at least fixed upfront, where option 2
Yep.
can easily exceed it depending. Any other cons for the third option?
Not that I can think of. Yeah.
Fred, if we could go to the, I think it's the next slide, slide 11.
Yeah, so we already covered this, right? Yeah, I never got to actually animate it, but I wanted to spend time before it was blocked all the text. So this is what it comes down to, right? Yeah, it comes down to which direction do you want us to go in? We can proceed with designing option 1, not upgrading the pump stations. That's a lower fee, or we'd start out working on option 2 or 3. We develop that through the 30% design. We've given a schedule there. And at the 30% level, we'd say, hey, we looked at everything. The best decision to go with is option 2 or 3. Do you agree with us? How do you want to proceed? That's really where we're at right now. We've completed our study. We have proposals to the town for those amounts. Tell us which way you want to go. Because the challenge is you got to come up with $2 million to make that happen. That's roughly the difference in the cost between what's already allocated and our current estimate. Yeah.
Does the town have any understanding of where we would get to 2 million to do this from?
I mean, I assume the bonding for it. That needed,
Yeah, we're also exploring some other possible opportunities. Can't say what they are yet, 'cause we don't know if they're viable, but when they become viable,
we would also look to see what we have in reserves and fees collected, so, and then move on with that number.
Are you guys gonna hang out for a little while? If we have more questions that pop up, can you hang out? And we can bring everybody back up here and,
Sure. Welcome. Yep.
okay. Thank you for the presentation. We appreciate it, and thanks for hanging out. I know it's getting late. So the first action item under the report of the town engineer, as a group, WPCA members, we have 2 options, right? Because there's for tonight's action items, there's 2 options, right? If we want to go forward with option 1, the design cost is going to be $394,000. Or we go with option 2 or 3 and approve for the design cost of those two, which respectfully, I think we all, I mean, those are the better plans. The engineers have told us that. And that's the two options we're looking at. So just the approving of the design of either 1 or 2 and 3. Does that make sense? So at this moment, because we have a group here, I'm looking for a motion.
Mr. Chairman, I make a motion to approve getting started with the funding for design option 2 or 3. I'll
second that.
Okay.
Mr. Ray, you got that one. Sorry. I'll be looking, though. Is there any discussion?
I just want for the record to say that as a collective, we've taken an initiative and we made a crucial investment to build a flood wall around this facility. And this is just another version of the type of work that we're trying to safeguard this specific institution that not services just me, but everyone and every family in Stratford. So for the long-term sustainability of our town, I think this is the right procurement to be moving forward with.
I would agree. I also believe very strongly in coastal resiliency as I started this meeting tonight. Is there any other discussion? Seeing none, all in favor?
Aye.
Aye.
Any opposed? So moved unanimously. Now we're going to move to item B under the town engineer. That's going to be looking to approve the amount of $559,000. Do I have a motion?
Yes, Mr. Chairman,
Mr. Llewellyn.
I make the motion to approve the stormwater improvement design fee of $559,000 even.
I'll second that.
Ms. Whittam. Any discussion? All in favor?
Aye.
Aye.
Any opposed? So moved unanimously. You guys are off the hook. Thank you for your time. We really appreciate it. Moving right along. Number 4 is the report from the Water Pollution Control Plant Superintendent, Mr. Hyde, and the purpose of time. If you could just stick to the action item tonight.
Yes, Mr. Chairman. On the August 25th board meeting, we approved $50,000 of funds towards the biofilter chip removal, disposal, and replacement. The bids have come in. That price, $50,000, had allowed for about a 30% increase over when we had done this in 2018. The bids came in. The low bid is $63,826. That's actually a 64% increase over the previous years. However, it is our best bid. It is the same contractor. The next bid was significantly higher. And so I request the WPCA board increase the approved funds for this project to $63,826 from the same account, 38938-6599. So the bid may be accepted and the project may be completed at this time.
Thank you. Before we open this to discussion, I'm looking for a motion.
So moved.
Frey, and then Chris. Mr. Green, seconded it. Is there any discussion? Seeing none, all in favor?
Aye.
Aye. Any opposed? So moved unanimously. 8, looking for a motion to adjourn.
I'll make the motion.
Mr. Frey?
I'll second.
Ms. Whittam? Any discussion? All in favor, say aye.
Aye.
9:29.